So I want to show you guys a general strategy whenever we're trying to solve a hard-looking question, such as this one right here. We have f of x is equal to 1 over 1 minus x, and our goal is to figure out f of f, so many of them. We have a total of 2025 of f's, and then the inside here is 2025. So at first you might be like, how is this possible? There are so many things that we have to do, right? Well, don't worry about it. Here is the strategy. First thing is, don't let this scare you. Usually, when the question looks scary, there's an easier way, alright? Secondly, watch my videos. They help, hopefully. Anyways, third one is the real one. Whenever you're trying to solve a question that looks complex or a lot of things happening, or like it's like repeating so much, there's usually a pattern. And in order to find the pattern, you just have to try from like small cases. What I mean by that is, I might not be able to solve this right away, but let's go ahead and just try to look for patterns. We know f of x equals 1 over 1 minus x. So if we put 2025 into this x, I just have to do the same thing right here for this x and then work that out. Good. But let's just stick with x, because next I would like to see what f of x is. So not just try small cases, and then usually there's a pattern, I'll tell you that. Okay, so in this case, f of x means that because this is that, so we just have to do f of 1 over 1 minus x. And to do this, we will have to put this into here, right? So it's 1 over 1 minus 1 over 1 minus x. Now, let's simplify this a little bit, and we can do so by multiplying the top and bottom by this little denominator, which is 1 minus x. And then we will have 1 minus x on the top, this times 1, and then this times this part, they will cancel, so it's a minus 1. And have a look. 1 and minus 1 cancel, and we have a negative x on the top, on the bottom. I can put a negative up here and negate the whole numerator, and then perhaps I'll distribute this a little bit. Negative x, I would like to write that down first, which is positive x, and then we have the minus 1. Okay, so that's what f of x looks like. If I have to plug in 2025 into here, I can plug in 2025 into here and here, which is 2024 over 2025. Not so bad. But now, let's do it again, because I don't really see a pattern yet. And sometimes you just have to be patient. Now, we know when we have f of x, the result is that. So we just have f of x minus 1 over x. And do the same thing that what we did. Put this into here. And then simplify this by multiplying the top and bottom by the denominator. So the top is just x. On the bottom, we have x. And be careful though, they cancel, but here is a minus, and technically there's an invisible parentheses. We will have to distribute the negative to this x, so that's minus x. Distribute this negative to a negative 1, so it's plus 1. Now here's the beauty. X minus x is just 0. So we have x over 1, which is just x. Yes. So what does that mean? That means actually it starts to repeat, because if we have 4 of them, f of x, 1, 2, 3, 4. When you see 3 f's like this, and then the input is x, this is just going to be x. So it's just the original f of x, which is 1 over 1 minus x. Let's answer this question. We are trying to get f of f. So many of them. And then let me just write down a couple more f of f. And then finally we have 2025. 1, 2, 3, and then 1, 2, 3. Okay, total of 25 f of them. Now, what we need to do is, notice that whenever we have 3 f's, we just get the x back. So for example, these 3 f's of 2025, you just get the input back, which is just 2025. Now, since we have a total of 2025 f's, we'll just have to see how many times we can put them into groups of 3. To do so, we can just do a long division. We'll just divide 2025 divided by 3. It repeats every 3 times. That's why we are dividing by 3. And if you work this out, we get 675. And the key right here is that you will have to know the remainder, which is equal to 0. That means here you see the first group, and in fact you can see the second group, third group, so on, so on, so on. And then lastly, you can also pair these 3 f's as another group. Altogether, we have 675 groups of the triple f's, f of f of f. Right? So what that means is, well, in fact, you're just going to get the input back as how it is. So the answer is 2025. Just like that.